Alright, this video is going to be on 4 big log rules that you're going to need to remember. So make sure you write these down in your notes and remember how to use them. The first rule we're going to go over is the addition rule for logs, which says if you have log base A of B plus log base A of C, that equals the log base A of B times C. All right. So when you add, when you add them and they have the same base, you can multiply together what you're taking the log of, and it'll be the same as log base A B times C. For example, let's simplify log base 2 of 2 plus log base 2 of 8. All right. So if we're following our steps here, we're going to have log base 2 of 2 times 8, which is the same thing as the log base 2 of 16, which of course equals 4. All right, and of course equals 4. All right, now there's a few rules for this rule. All right, there's a few rules for this rule. Number one, must, must be the same base. All right, remember your base is that little number. It's like that subscript number. All right, they must be the same base. So if you had something like the log base 2 of A plus the log base 3 of B, well, you can't use this rule. Right? You can't add those together using this rule because they have different bases. Right? They have to have the same base in order to use this rule. All right, so for this one, it's just tough luck because you can't use it. All right. Also, second rule for our addition rule. Logs can't have coefficients. Forgot my E. All right, logs can't have coefficients. So for example, get that out of the way. So for example, you can't do 2 times the log base 2 of 2 plus 3 times the log base 2 of 4. All right, that's another tough luck. You can't use the rule. They can't have coefficients. All right, so little review. Log base A of B plus the log base A of C equals the log base A of B times C. So the log base 2 of 2 plus the log base 2 of 8 equals the log base 2 of 2 times 8, which is log base 2 of 16, which gives you 4. Remember, they must have the same base and they can't have coefficients. Right? These would be your coefficients if you're not sure. All right, they can't have coefficients. All right, second rule I want to look at is the subtraction rule. All right, so log base A of B minus the log base A of C equals the log base A of B over C. All right, when you subtract logs, you when you combine them into division, and it's always the first one. That's supposed to be an arrow. It's always the first one over the last one. All right, that's why this is B over C. Log base A of B minus the log base A of C is the log base A of B divided by C. All right, so if we go down here to this example, let's simplify the log base 3 of 18. It's supposed to be minus the log base 3 of 2. All right, so following our rule, it's going to be the log base 3 of 18 divided by 2, which is the log base 3 of 9, which is of course 2 because 3 squared is 9. Just remember your spiral that I told you about. All right. Now, the same rules apply to this. Okay. So the same rules as addition. All right. So they have to have the same base and no coefficients. All right. Same base, no coefficients. It's the log of the first one divided by, it's the log base 3 of the first number divided by the second number. Log base 3, 18 over 2. All right. Let's look at our third rule. Our third rule is our power rule. So in this case, when you have a coefficient in front of your log, so c times log base a of b equals that coefficient can come around and be the exponent on your b. So log base a of b raised to c. All right. Now this rule works both ways. You can use it to take your exponent and bring it up if you need to and get it out of the front. So then you could use the addition or the subtraction rule. Or you can use it to put your exponent down in the front if you need to for some reason, which a reason we'll go over later. All right. So you can either pull it up or bring it down. All right. So let's simplify this. 2 times the log base 3 of x plus 3 times the log base 3 of y. So before, with addition rule, we can't do this, all right? But if we apply the power rule, those exponents will lift up, and it'll be the log base 3 of x squared, because the 2 will become the exponent on the x, plus 3 log base, log base 3 of y cubed. That 3 will come up and be the exponent on y. All right, so now we have no coefficients, we have the same base, and since this is addition, it is simply log base 3 of x squared y cubed. All right, so we actually used two different rules to simplify this. First, we had to use power rule to lift up or pull up our coefficient and make it an exponent on both log terms. After that, we can use the addition rule to simplify it. All right. So let's look at, I guess we don't need to do another example. All right. I guess I'll do one. So 2 log base 2 of 5. All right. Again, this 2 will lift up and become the exponent. So this would go to the log base 2 of 5 squared, which of course equals the log base 2 of 25. All right, the log base 2 of 25. All right. Now, just as a little proof to prove that, this is 2 times the log of 2 base 5, which means you could also write this as the log base 2 of 5 plus the log base 2 of 5, correct? Because if you have 2 times 4, okay, it means you have 4 plus 4. 2 times 4 and 4 plus 4 are the same thing. Same thing here. 2 times this is the same thing as adding them twice without the coefficient. All right, so that would equal, darn it, let me control Z that. All right, there we go. Now, let me take this out again. Take my 2 out. All right, let me try not to take my 2 out this time. All right, so that would be the log base 2 of 25, which is, of course, the same thing that we have up there. All right, so that's just kind of a little proof of the power rule. All right, you just lift up your exponent, and it becomes your I'm sorry, you lift up your coefficient and it becomes your exponent. All right. Now the last one, and this is usually the most confusing one, but it's not that bad. To me, it's not confusing at all. All right. If you have the log base A of B, all right, the log base A of B, if A is not either 10 or E, which in this case, if it was E, this would be a natural log. But if it's not 10 or E, if C is some other number, all right, sorry, A, if A is some other number, what you're going to do is you're going to do the log base C of B, log base C of B, divided by the log base C of A. The way I tell people to remember this is draw a little fraction bar between these two. Okay, draw a little fraction bar. So it's going to be B over A. Okay, and if you notice, it's B over A. Now what you want to do is you want to choose your C, your base, as either 10 or E. All right, because both of these, now if you're using the Inspire, you can change the base, but most calculators, you can't change the base of your log. So you either have to leave it as 10 or E in your calculator. You can't change it. But if you, but say this is 13, or if you look in our case here, 7, all right, you can't, in a normal calculator, you can't do this. You can't change the base to 7. You can in the Inspire that we use in class, but you can't like on a TI-84 or something like that, all right? So what we're going to have to do is we're going to have to make this, you can either go log base 10, which is what's in your calculator, of 11, all right, because this is our B value, divided by the log base 7 of 11, all right? Or, remember how I said either 10 or E? If you make it 10, I'm sorry, I made a mistake right there. I don't know why I wrote that like that. All right, it would be log base 10 of 7. Sorry about that. All right, so here we changed our base to 10, but if you changed it to E, this would also give you the natural log base E, I'm not going to write it, of 11 divided by the natural log of 7. Both of these are going to give you the same answer. All right, so now you can take the log base 10 of 11 or the natural log of 11, all right, and get 2.398 over log base 10 of 7 or natural log of 7, 1.946, which in turn will give you 1.23. All right, so your change of base formula, it's the log and then either pick 10 or E. If you pick E, you're going to have a natural log. So you're going to have log base 10 or E of B, which in our example here is 11. So log base 10 of 11 over log base 10 of your previous base. Okay, the base that's actually in your original problem here. All right, log base 10 of 7. Like I said, you can kind of draw a little fraction bar in there. So it's log 10, the base 10 of 11 divided by log base 10 of 7, or natural log 11 over natural log of 7. Both ways will give you the same answer. All right, let's do a you try. I want you to find the log base 13 of 9.2 using your calculator. So pause the video for a few moments and figure this out. All right, so let's go ahead and rewrite this. Let's do natural log of 9.2 divided by the natural log of 13. All right, if you do the natural log of 9.2 first, you're going to get 2.219 divided by the natural log of 13, which is 2.565. Alright, so 9.2 natural log divided by 2. Alright, you should get 0.865. Alright, if you got 0.865, you did it correctly. Alright, so there's no ticket in the door for this video. Those are your 4 big log rules. Make sure you know them, make sure you know how to use them, and make sure you can even combine them if you need to. What do I mean by that? Well, if you remember on that one example for the power rule, we had to simplify that log. We lifted up the coefficients, made them exponents, and then combined them using the power rule. I mean the addition rule. All right. So make sure you know what these rules are and how to use them before you come to class tomorrow. Good luck.